Hello guys, this is Edexcel Science channel and now we are at question 15. In a high jump competition, athletes jump over a bar. An athlete has a weight of 680 newtons. The athlete exerts a force of 890 newton on the ground as he jumps into the air. Explain why the athlete accelerates upwards. Your answer should refer to Newton's third law. Now, for a question like this, it is always a best practice to make a rough diagram so that we understand the scenario better. Let's say that this is the athlete. Okay, let me make him a little bit more bigger. Okay, this is the athlete. He has a weight of 680 newtons. Now, let's say he wants to jump. When he is jumping, he is exerting a total force. He is exerting a total force of 890 newtons. Now, when he exerts this force, right, the ground is going to exert an equal and opposite force, which is 890 newton as the normal reaction force. However, this force is greater than the weight of the athlete. That is why he has a resultant force that is going upward, and since the resultant force is upward, the acceleration is also upward. Now, if we want to write the answer, we can just write that by Newton's third law, the ground will exert an upward force of 890 newton. Then you can say that the upward force is greater than the weight of the athlete. Therefore, there is a resultant force upward. That is our answer. Moving on to question number B1. The athlete moves horizontally as he passes over the bar. The kinetic energy of the athlete is 409 newtons. 409 joules. Show that the athlete has a horizontal speed of 3.4 meter per second. Now, we know that the formula for kinetic energy is half mv square. So we can just use this formula. However, the moment you try to do this, you will notice that we do not actually know the mass of the athlete. However, in question number A, they told us that the athlete has a weight of 680 newtons. So we can do something like this. Weight is equals mg. So m is equals weight divided by g. 680 divided by 9.81. It should give us 69.3 kilograms. So over here it should be something like v square is equals 409 times 2 divided by the mass, and if we remove the square it becomes a square root, which gives us approximately 3.436 meter per second. Now, question number B 2. After passing over the bar, the athlete moves through a vertical distance of 1.4 meters before he lands. Calculate the velocity of the athlete as he lands.